If not, let me know. I'm starting with the topic that is the first chapter, number system, and I'm starting the revision from the very first chapter. These revision, like here, I'm discussing all the important concept, and all the important questions related to this topic. I'll be taking that, and after this class you also revise, you also solve all the question from your book, from the revision worksheet. If you are having, just solve different type of question from the same chapter, and do let me know in the next class if you are having any doubt from here. Okay, so let me start with number system. Okay, so first thing first, here we will be talking about the irrational numbers, rational numbers. So you must know that we are having a Venn diagram, or a diagram you can say like this, where we are having natural number, then whole number, then integers, and then rational number. So we can say, just a moment, no? So we can say that all the, like, natural number, whole number, integer, all natural number, all whole number, all integer are rational number. If we are talking about rational number, you will be focusing on this bigger circle only. The rational number is this bigger circle. Now this bigger circle is containing integers also, whole number also, natural number also. That's why in like fill in the blanks type of question, or true false type of question, you have seen such question where we say that all whole numbers are rational number. Is it true or false? It's true. All natural number are rational number. Is it true or false? It's true. All integers are rational number. Is it true or false? It's true. So this diagram, you can keep it in your mind. Whenever you get confused, you can just visualize it and you can answer that. Okay. Similarly, we can say, yeah, similarly, we can say integers. If we will focus on this next circle, that is integer, then we can say all whole numbers are integers, all natural numbers are integer, all rational numbers are integers. No. So inside the integer, whatever is there, that is in like integer. We can say natural number, all the natural numbers are integer, all the whole numbers are integer. So if this type of statement you are seeing anywhere, that will be correct. Okay, similarly it's for whole number, similarly it's for natural number. So you can just keep this picture and you can draw it in your copy. Whenever you get confused while doing fill in the blanks type of question, or true false type of question, you can get back to this picture. Or rational number, you can also understand it that way, that rational numbers are the number which can be written in the form of p by q, where p and q both are integers, but q must not be 0. So we know that in mathematics, whenever we are having any fraction, the denominator should not be 0. That is the one thing we have to be careful. Whenever the denominator of any fraction is 0, that is not defined in mathematics. Okay. In rational number also, the definition says it has to be in the form of p by q, where p and q are integer, but q must not be 0. Okay, that is the definition of rational number. Integers, what are integers? Integers are the number which can be represented, which we used to represent on the number line like this: 0, plus 1, plus 2, plus 3. Here minus 1, minus 2. These are the numbers which are integers. Okay. So Let's move ahead. Yes, Riaz, we have started the revision of each and every chapter, each and every topic, which will help you in the final exam. Okay, so for uh, for that we have just started the revision. We have just started with the first chapter. We will be covering all the important question and concept related to, like, from this chapter. Then we'll be moving with the next chapter. Quickly we will do the revision of each and every chapter. I am also expecting question from your side, which you are going to ask from the chapter which will today. I have taken number system, so if you are having any doubt from number system, anywhere you are, like, you are not so sure, you are just confused, you are having doubt, you can ask me today or in the next class also. Just collect all your doubt and ask me in the class. This way, quickly, we will be doing the revision, which will help you a lot before the exam. It will only help you when you are going to practice it. Here, we will be discussing the concept. After the class, if you are going to practice the same chapter, and then in the next class, if you are asking your doubt, then and only then you will be sure about one of the topic. Okay, this is prepared. Keep it aside. Let's move to the next chapter. This way, you can prepare for the exam. I am helping you, but the same effort you also have to apply. Then only you will be sure about any topic. Okay, let's move ahead.
Okay.
So this is about, today I have started number system. Okay, I believe the whole syllabus is already covered in your batch. If not, do let me know. I'll be taking that topic at first, that chapter at first. If any chapter, if we have missed any chapter, let me know. I'll be taking that chapter at first. We'll be explaining that, and then we will start the revision. We'll continue the revision. So, if the whole syllabus is covered or not?
Yes, ma'am. Good.
It's covered. Okay, let's continue. So this is all about the rational number, integer, whole number, natural number. Yes, Riaz, I have drawn this picture to so that you will be clear. Most of the time, I have seen a student get confused if it is written in the statement form that all the whole numbers are rational number. Then a student start thinking, is it so? All the whole numbers are rational number or not? So this figure you can keep in your mind to understand that outside circle is rational number. So you can see whole number is inside the rational number. Here we are having the whole number. It is inside the rational number. It is inside the circle of the rational number. So yes, all the whole numbers are rational number. All the natural numbers are rational number. All the integers are rational number. Okay, this way you can understand it. If it is not inside it, then you can say it's not true. So if the statement says uh, all the rational numbers are whole number, all the rationals are whole number, so rational is inside the whole? No. So all the rational number are not whole number. Okay, whatever is inside the circle of whole number, that is, like, all natural number is whole number, we can say. Okay, if I am talking about integer, then I can say, we can say all the whole number is integer, all the natural number is integer. So जो भी इंटीजर सर्कल जो बन रहा है उसके अंदर आएगा, उसी को बोल सकते हैं कि सारे होल नंबर्स इंटीजर्स होते हैं, सारे नेचुरल नंबर इंटीजर्स होते हैं, सारे रैशनल नंबर इंटीजर्स नहीं होते, क्योंकि रैशनल इंटीजर के बाहर है. इफ यू अंडरस्टैंड हिंदी एज वेल. ओके, लेट्स मूव अहेड. Now one concept was related to rational number, like five, write five rational number in between 1 and 2. So there was one shortcut. If we have to write five rational number in between 1 and 2, what we used to do? We used to do 5 plus 1, which is 6. So we will be making the denominator 6 over here and denominator 6 over here. Okay. Since the denominator is 6 over here, you must have done this type of simplification where 1 by 1 is equals to 6 in the numerator what we can do. So here we used to do 1 multiplied with 6 is 6. So in numerator also we need to do the multiplication of 6. So it became 6 by 6. Similarly 2 by 1, and here 6, here fill in the blanks. So 1 became 6 with the multiplication of 6. So 2 also we will multiply 6 and it will be 12. So 1 became 6 by 6, 2 became 12 by 6. Now we have to write the 5 rational number in between 1 and 2. 5 rational number in between 1 and 2 will be 6 by 6, 7 by 6, 8 by 6, 9 by 6, 10 by 6, 11 by 6. This way we can write 5 rational number in between 1 and 2 or in between any number. Okay. If 5 rational numbers are there, we can make the denominator 5 plus 1, that is 6. If 6 rational numbers are there, we can, the bare minimum we can make it as a 6 plus 1, that is 7 as a denominator. Okay. This was also one of the concepts. Just tell me anywhere why, I'm just keep on, just I'm continuing with the explanation. If anywhere anything is not clear, please tell me. I'll take a pause over there and will explain it again. So this was the next concept. The other concept we were having, it was irrational number. Okay, so the concept was, the first thing was, you need to know that decimal number are of two types: terminating decimal number, non-terminating decimal number. Terminating decimal number, that means termination. Any person got terminated from the reality. So that means like from they just uh, termination means stoppage. Okay, or they just excluded from there. They just got out from there. So termination means stop. Terminate means to stop. So terminating decimal number means we are having the example of terminating decimal number can be 2.53, 7.25, 8.26. So these are the example of terminating decimal number. Why I am saying terminating decimal number? Because you can see after a certain digit, the decimal number is getting stopped. Termination means to stop. Non-terminating means it will not stop. It will just keep on going. So non-terminating decimal number example is this one. Non-terminating decimal number example can be 5, 6, 7, 8, 9, 2, 3, 4, dot, dot, dot. Okay, it will just keep on going. It will keep on going and keep on going and keep on going. It will never ever stop. So decimal number will be of two types. Either it will stop or it will not stop. That's it. Now non-terminating decimal number is having two different types. So this non-terminating decimal number is having two types, that is recurring decimal and non-recurring decimal. Recurring decimal number are, the example of recurring decimal number is 3.25 dot on the head. That means 3.25, 25, 25, 25, 25, recurring, reoccurring. Okay, 25, 25, 25, 25. It is 25 is reoccurring. That is called recurring decimal number. So non-terminating, whenever it will not stop, two cases can happen. Whether it will follow a certain pattern, it will reoccur, 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 and will not stop. And the next type is non-recurring. That means it will not stop and there will be no number which will reoccur. Very random numbers will be there. So the example for that will be 5.25378642 5 3 2 4 8 7. Very random number will keep on coming. It will not stop, but a very without having any pattern. So again, to summarize everything, we are having decimal number two type: terminating, non-terminating. Terminating, it will stop; non-terminating, it will not stop. When it will not stop, two cases can happen: either there will be a certain repetition, and it will just not stop, or there will be no repetition of number, very random number will keep on coming. Okay, so whenever we are having terminating decimal number, those are rational numbers. Whenever we are having non-terminating, two cases are there: recurring, non-recurring. So this is rational and this is irrational number. So irrational numbers are the number which are non-terminating and non-repeating. Non-repeating means non-recurring. Irrational numbers are numbers which is non-terminating, non-repeating. Okay, terminating numbers are rational number. Non-terminating, if recurring number, if repeating number is there, that is also rational number. Now, you must know that root 2, root 3, root 5, root 8, root 7, these number which are not perfect square, these numbers are irrational number. Why it is irrational number? When you will find the value of it by long division method, you will get a very random decimal number where it will not follow any pattern. It will keep on going, keep on going, but will not follow any pattern. It will not reoccur. Nothing will reoccur. The numbers will reoccur. Obviously, the numbers will reoccur like this. The number will, maybe the number will reoccur 2 5 3 2 5 7 8 2 9 6. So if you are thinking 2 is here, 2 is here, 2 is here, so number is just repeating. But I am not talking about the number repeating. I am talking about there is no pattern. Pattern means if we are having 3.821, again 821, again 821, again 821, can you see the pattern? 821, 821, 821. This is the pattern which I am talking about. Here in the other one on the right hand side, you can see there is no pattern and it is just continuing. So such numbers are called irrational numbers. Okay, and whenever the pattern is there, it is called rational numbers. So this type of irrational number explanation we are having in this chapter. Apart from that, fractional number also we are having. Uh, let's say 23 over 7. Just find the decimal number for this one, divide it and find the decimal number. Or maybe 5 by 7, divide it and find the decimal number for that. You just have to do the division and you have to find the decimal number. One more thing, one more concept is there in this chapter, that is to represent root 2 on the number line, to represent root 3 on the number line, to represent root 5 on the number line. Do you know how to represent root 2, root 3, this type of number on the number line? Do you know? First, we will be taking a straight line. Here we will be pointing the origin O. The origin O. From here we will be taking 1 unit. Then here we will be drawing one unit perpendicular, and then we will join it, and that will be root 2. Why it will be root 2? By Pythagoras theorem, we know whenever we draw perpendicular and we make a triangle, then hypotenuse square is equals to base square plus perpendicular square. So base is also 1, perpendicular is also 1, so it became 2. So hypotenuse became root 2. Okay. So this is how we can draw root 2. We can measure root 2. This root 2, we can measure it with the help of compass, and then we can make an arc like this. And here we can say this total distance from 0, from the origin, or from 0, this total distance is root 2. From, with the help of your scale, root 2 you won't be able to draw. Okay, in your scale, in your centimeter scale, root 2, root 3, this is not there. That's why this is the whole process which we follow for making the figure, like for drawing the distance root 2, for representing root 2 on the number line, for representing root 3 on the number line, like that. If we have to draw root 3, then here only we can say this is root 2. Okay, here we will be dropping a perpendicular distance, that is 1 unit, 1 from the centimeter scale, and then here we will be joining to get root 3. Okay, so this is how we will be doing the construction. This root 3 distance, we will measure it in the compass, and then we can make an arc over here, and then we can say from 0 this much distance is root 3. So this was also there. Now the rationalization concept is there. Okay. So the rationalization concept is there. If we are having 1 by 2 plus root 3, can you tell me how to rationalize it? Anyone? Please let me know
Yes, ma'am.
how to rationalize it.
Now we will multiply it with root 2 minus root 3 divided by 2 minus root 3.
Exactly. And then we will be able to rationalize it. Uh, we are having 2 minus root 3 in the numerator, and in the denominator we are having 2 square minus root 3 square. So basically we want to remove the root sign from the denominator. For that we are doing this arrangement. Now if we are having 1 by root 5, can you tell me how to rationalize it?
Yes, ma'am. Root 5
Yeah. If we are having 1 by root 5, how to remove this square root sign from the denominator?
into minus root 5.
Into
Minus root 5.
we can multiply only root 5 and only root 5. So basically whenever we are doing the rationalization, or whenever we want to remove the square root sign from the denominator. Okay, in mathematics whenever we get the answer and whenever there is a square root sign in the denominator, we try to remove that. Okay, we don't leave our answer like that. So from the denominator square root sign, we always try to remove it. And for that, whatever way it is working, we do that. So for the first one, making a square b square formula, a square minus b square formula, we were able to remove the square root sign from the denominator. In numerator, if a square root is there, whatever is there, well and good. In denominator, we just don't want to keep the square root sign. For that only you are learning this method. Here for the second one, minus root 5, only root 5 will work. You can see if we are having 1 by root 5, and if you will multiply only root 5 over here, only root 5 over here, in numerator root 5 is there, it's okay. In the denominator, root 5 into root 5, in denominator root 5 into root 5, these two will collaborate with each other, these two will come together. So in denominator we will be having under root 5 and 5 both will come together, both just talk with each other, and they said okay, let's just sit inside the one root sign, and they just came together. Once they came together, they made a pair, and now we are having pair of 5, that means 1 5 will come out. So we will be having root 5 by only 5. In the denominator everything is okay, but we don't want a square root sign, and we were able to do that by multiplication of root 5 in the numerator and denominator. Is it clear? This will be our answer. Is it clear? So for removing the square root sign from the denominator, whatever works, if any formula works, go ahead. If only multiplication of the number works, go ahead. Whatever works, do that. And just remove the square root sign from the denominator. Getting it? One more concept is there, to write the number like 3.25 in the form of E by Q. So for writing this type of number, here again I am saying this is the decimal number, and the name of this decimal number is non-terminating. You can see there is no stoppage. 25252525252525. It will keep on going. Non-terminating, repeating decimal number. Okay, or repeating you can write, or recurring you can write. So this decimal number is non-terminating, repeating decimal number, or non-terminating, recurring decimal number. Okay, reoccurring. Recurring, reoccurring, we don't have to write. Recurring, we say the meaning of that is it is just the numbers are reoccurring. So when I will write 3.56, which type of decimal number is this? This is terminating decimal number. Terminating decimal number means rational number. This is also a rational number. Okay. So we have to write this rational number in the form of P by Q. If you have learned the process, you must know that we take 3.25, we take it as a X. 25, 25, 25, dot, dot, dot. We take it as a X. Now, how many numbers, how many digits are repeating itself? I can see 2 digit, 25, 25, 25. 2 digit is repeating itself. So, we will be multiplying 100 over here and 100 over here. So, it will become 325.252525. Now, we will have two equation. We will be subtracting 2 minus 1. We will be having 99x over here. We will be having 325 minus 3. That if you will do the subtraction, you will find that here we are getting 322. Okay, and rest of the thing will get removed. Just a moment now. So our x value will be 322 over 99. This is how we can represent it in the form of P by Q. Now, like each and every concept I have touched over here, the last concept over here was the rule of exponent. So we were solving the question related to where the exponent rule were there. Let me take those question also. Okay, so if we are having 125 to the power negative 1 by 3, how can we go ahead and apply the rule of exponent over here? This one. Let me know. Can we write it as a 5 to the power 3? 125 as a 5 to the power 3. And then whole is having power negative 1 by 3. Now we can write it as a 5 to the power 3 into minus 1 by 3. Which rule we are applying over here? So we are applying a to the power m to the power n, which can be written as a to the power m into n. So we have multiplied both the power. We can just cancel them. We got 5 to the power minus 1 over here. Now this 5 to the power minus 1 can be written as 1 by 5. Okay, 1 by 5 to the power 1. Here, which rule we are applying? You know that a to the power minus m can be written as 1 by a to the power n. This rule says whenever we are having any number, if you are switching its place, if you are making the number sit from numerator to denominator or from denominator to numerator, whenever you will switch its place, the power will reverse its sign. If it is already negative, it will be positive. If it is already positive, it will be negative. So if you are having 2 to the power minus 2, it will, in the denominator, it will be 2 to the power 2. If you are having 1 by 5 to the power negative 6, if you will switch the place, you will make it sit in the numerator, the power will become positive. If the power is already positive, let's say power is 2 to the power 3 in the denominator, and if you are switching the place, then the power will reverse its sign. So you should understand this property, that this property is not only applicable for the negative power. Basically, this property says when the power is positive, it will become negative. If it is negative, it will become positive when you are switching its place, when you are making it sit from the numerator to denominator and from denominator to numerator. Okay, let me take few more questions from here. So if we are having 11 to the power 1 by 2 over 11 to the power 1 by 4, here which rule, which exponent rule we can apply? So we can apply the exponent rule, which is a to the power m over a to the power n, can be written as a to the power m minus n. The same rule we will be applying over here. So 1 by 2 minus 1 by 4, we will be taking the LCM, that is 4, and here we will be having 2 minus 1, so basically it will become 11 to the power 1 by 4. Are you getting it?
Yes. Yes, ma'am.
Now if we are having 32 to the power 2 by 5, anyone let me know how to do this one?
Is it 3 square? Is
No,
it
it's
possible?
32. 32
32.
to the power 2 by 5.
Ma'am, you will 32 you'll write as 2.
2 to the power 5, right? And whole is having 2 by 5, then what?
Ma'am, you will cancel 5 5.
Exactly. We will be cancelling 5 and 5 and we'll be getting 2 to the power 2. When the power is smaller, we can just do the multiplication, we can write it. When the power is bigger, like 31, the power is 31, the power is 30, the power is 40. Just write the answer as it is. That is our final answer. Now, if we are having 2 to the power 2 by 3 times 2 to the power 1 by 3, what to do over here? Anyone? What to do over here?
Yes, ma'am.
Any idea? Do you know this property? A to the power m into a to the power n says we can write it as a to the power m plus n. So basically we can write it as a 2 to the power. Here bases are same. When the bases are same, what is called base? Base is this one. This one is base, this one is base. Here a is base, here a is base. When the bases are same and both are in multiplication, the power can be same, can be different, doesn't matter. Okay, when the bases are same and both are in multiplication, we will be adding the powers. So let's add the power. So we will be having 2 to the power 2 by 3 plus 1 by 3. So we will be having 2 to the power 3 by 3. That means 2 to the power 1. 2 is the answer. Okay, when the bases are same and the power can be same or different, you can apply the same rule. When you are having 5 to the power, let's say 3 into 5 to the power 3. So the bases are same. The power can be same, can be different, doesn't matter. So we just have to add the power. So we will be having 5, 3 plus 3. That means 5 to the power 6 will be the answer. When the bases are same and the powers same or different, if both are in multiplication, then we will be adding the power. When the bases are different, like yeah, one more property was there. When we are having a to the power m by a to the power n, we can write it as a to the power m minus n. Here the bases are same and both are in division. Power can be same, can be different, doesn't matter. So the example for this one can be 2 to the power 5 over 2 to the power 3. Base 2 and 2 same. Power can be same, can be different, doesn't matter. We will be subtracting the power 5 minus 3, that is 2 to the power 2. If the power is same, what will happen? So if the power is same, 2 to the power 5 over 2 to the power 5, and if the instruction says to apply the rule of exponent, we have to apply the rule of exponent. Cancel them, the answer will be 1. Please don't cancel, because here we need